question 3, we've got the depth of a stream here, and they've got the graph beside it going from there to there. And you can spot, of course, at that point there is 0. And you know that this part here is 3, because that's when x squared minus 3x equals 0. So we're going from 0 to 3. Of course, what would happen if you were more than 3 is it would start going up into the air there, and the depth of the stream can't be up there. So I think you're just going to say the stream is 3 meters wide. Would be my interpretation of why you're going from 0 to 3. Now, part B asks us, of course, to differentiate this thing. So we've got a differential here with a product rule. So u equals the first bit, and v equals the second bit. And we'll differentiate this. Differentiating this just gives us minus 0.6 e to the minus 0.6x, and differentiating the v, dv by dx, is 2x minus 3. So those two things times together is minus 0.6 e to the minus 0.6x times by x squared minus 3x, plus these two bits times together, e to the minus 0.6x, 2x minus 3. Still on the board? Right, what does it... So that is d dashed of x there, but they're asking us to show that it can be tidied up. So if we take the e to the minus 0.6x out, and they want us to take out fifths as well, don't they? So, right, fifths. If you're talking about fifths here, minus a fifth. You know what? I'm not going to take a fifth out yet. I'm just going to take that out first. No, we do need to, don't we? Right. This is 3/5, isn't it? So what we've got here is 3 lots of, we're taking the minus out as well, 3 lots of x squared minus 3x. If we're taking a 1/5 out of this, well, there's no sort of fraction here, so we've got a 1 here, and 1 is 5/5, so I've got 5 lots of those. And even then I've made a mistake, because this is a minus, so we're going to need minus minus in all of that. Right, what does this tidy up to give then? I've got 3x squareds minus 9x minus 10x plus 15. And so finally 3x squareds minus 19x plus 15. Minus 1/5 e to the minus 0.6x. That's what I've got. Right, part C. Oh, I've got to do it 3 times again. Part C, when does this equal 0? So 0 equals all of that. Now, look, clearly this can never equal 0. E to the x never touches 0. So all we need to do is try and find out when this quadratic can equal 0. One way of doing that is by adding the 19x's and take away the 15 and divide by the 3 and then square root. And so there's the first one. Of course, I didn't show that. You'd need to do that step by step, but I talked it through, didn't I? This one here, add the 19x's to both sides and then divide by 19. And so here's the second one. And for the third one, similar to, oh, so no, we'll do it again. The third one over here, add the 19x's and take away the 15 equals 3x squared, and then divide both sides by 3x's. So I've got 19x plus 15 divided by 3x. So put in that first iterative formula in the calculator, starting at 1, it then gets, after a little while, it's coming down to 5.4089, isn't it? 5.4089. And here's the second one, starting at 1 again. And this time we're going to 0.924 for that one there I've got. And the last one, starting at 1, and this one goes to 0.924. Now, answering the question, what do you do when you've been videoing for 5 minutes and 34 seconds and you notice a negative slip? Look, that should have been a minus there, shouldn't it? And I've spotted that because this didn't go to where I expected it to go. This is what I was expecting to happen. I was expecting it to go to 5.4089 again. So there. Look, that one there isn't in the 0 to 3 range. That one there is not in the 0 to 3 range. And so this is the X value that must give the minimum depth. And if you put that 0.924 back into the original equation at the very top of this and find out what the depth is at 0.924, it turns out to be minus 1.1018, so 1.10 meters deep.